Have a nice day. And for this video, I am going to discuss about equilibrium of a particle. Here's a sample picture of an equilibrium. So, and total force acting to the right is just equal to the total force directed to the left. So the resultant there is zero. Balanced forces. So what is equilibrium? Ang definition sa equilibrium is this. When the resultant of all the forces acting on a particle is zero, the particle is in equilibrium. So, when the resultant is zero, equilibrium na. So, let's recall. The resultant is the sum of all forces acting on a particle. So, for this one, i-equate na to sa zero. Okay. And if you use components, instead of parallelogram method, if you use components, then we can extract this one, summation of force, ito component. Summation of force equal along x equal to 0. Muna ang Rx, di ba? So, if the total resultant is 0, it means ang components niya 0. So, dili pwede na if ang total total resultant is 0, Rx is equal to 1, and then Ry is equal to -1 para makancel. Dili pwede kay is ma-square man to, diba? R is equal to square root of Rx squared plus Ry squared. Diba? So, dili pwede nga opposite og sign kay ma-square man. So, if the resultant is equal to 0, it means na ang components niya 0 sad. So Rx being the sum of all forces along x must be equal to 0. Same also with y. So Ry, which is the sum of all vertical components, must be equal to 0 also. Sample, a particle which is acted upon by two forces, let's consider two forces only. A particle which is acted upon by two forces will be in equilibrium if the two forces have the same magnitude and the same line of action but opposite signs. And the resultant of the two forces is then 0. Okay. Again, dapat same of magnitude, same line of action, horizontal sa duha or vertical or maki-inclined, basta same line of action. And the third one is opposite of direction, opposite sense, opposite in direction. So to illustrate, inaan isa. Suppose mo ni ang isa ka force, 50 newtons, tapos 40 degrees from the positive x-axis, first quadrant. So para equilibrium, dapat i-balance niya og isa ka force having the same magnitude, same line of action, but opposite in direction. Okay, this one. So, same magnitude, and then same line of action, of course. So, ang direction niya, 40, yapon eh. Na-opposite sila o ang angle niya, 40 degrees, opposite the direction. Kini first quadrant, this one, third quadrant. Okay, sample lang nisa sa equilibrium for two forces. Now, in analyzing static problems, it is very important that you know about free body diagram. Okay, so the free body diagram, or in short, FBD, of a body is a sketch of the body showing all forces that act on it. So dihan nimo ipakita ang tanan forces nga nag-act sa body. The term free implies that all supports have been removed and replaced by the forces or reactions that they exert on the body. So, i-isolate nimo tong body. Tanan nga nakakonect sa body, i-remove to, i-replace din nimo to sa og force, reaction. Yan. Okay. Sample, like this one. Okay. Ang point of concurrency yan is, diri gamit tanan forces. Di ba? Diri gamit tanan forces. So, if we isolate this one, ato ni ikat. If we isolate point A, ikat na to, ikat siya na to ning kini AB, chord AB, and then this one, kini weight, ikat na to. Pero, butangan na to o forces. So, this is the free body diagram. Because since we are on the topic particle, dapat ang focus nato is on the point of concurrency where all forces meet. Yeah. In this case, it's point A. So sa point A, i-identify nimo tanan forces nga nag-act sa point A. Okay? Okay. So i-cut na to. Cut, dire, and then i-cut siya na to ng create. And then we replace it by the force. There is a chord na easy. Tension na siya. Okay. Basta chord tension mo na. Decide for tension. And then, in direction 30 degrees from the horizontal. And then we have this one. Tension EB. Angle niya 50. And then, pag-cut sa dire, nasa take rate. W. Okay, wala mang specify sa W. This is your free body diagram. So dire makita nimo tanan forces nga nag-act sa dire at point A. So every time you draw the free body diagram, make sure na na-account tanan forces nga nag-act. Dapat walay ma-miss na force, wala pa ma-add na force. But you add something na wala nag-exist, okay, wrong sa na siya. So, dapat ma-identify nimo correctly tanan forces, all forces that act on the particle. So, just make sure na there are only two unknowns. Okay? Since we only have two conditions of equilibrium that we can use. Summation of force along x equal to 0, summation of forces along y equal to 0. Now, in this case, W should be given, and then, therefore, ang ano na to is TEC and then TEB. So, after this, okay, you extract components, and then you sum up forces, and then after that, you equate to 0, and then you solve for the unknown forces. Inana lang ang analysis sa equilibrium. Okay. Let's have our sample problem. The crate weighing 500 newtons is supported by 3 ropes at B. Find the forces in ropes EB and BC if P is equal to 1,000 newtons. So, again, as I have said, there must be two unknowns only. Since we only have two conditions to use. So, unknown ang force sa AB and then unknown ang force sa BC. P is given, weight sa crate is also given. Okay? So, after this, we draw the free body diagram. Okay. This is your FBD. Okay, this is point B. Okay. You have 1,000, 30 degrees, and then you have the weight, 500 newtons sa crate, and then you have this one, TBC, 60 degrees tension, dira. Pero pag dili ka sure, you can just assume tension, and then pag negative, and therefore compression siya. Pero cable man tension din siya. Dili ma-design ng cable for compression. And then TBA or TEB. Depende lang. No? Usually, pag sa B, gikan, TBA. From B going to A. Same lang, no? TBA. After this, and then make sure that all forces must be either horizontal or vertical before you use the conditions. Therefore, for all inclined forces such as P and TBC, you have to resolve these forces into X and Y components. I-resolve na nimo. Kana, no? Horizontal, that's 1,000 cosine 30, and then vertical, 1,000 sine 30. As well as TBC. Extract nimo, resolve X component, that's TBC cosine, TBC sine 60. And then simplify, you get the values of this. Okay, ano. And then after this, since all forces are already either horizontal or vertical, then you can apply the conditions. Summation of force sa X equal to 0, no? And our sign convention is force going to the right is positive. So we only have three forces. This one, 866.025 plus, and then negative 0.5 TBC, and then also TBA. So we have two unknowns. Okay, this is equation 1. And equation 2, the second condition is summation of force sa y equal to 0. And again, we have three forces also. This one upward, positive, negative, and this one. And from here, you can solve for TBC, 1154.7. And then after this, i-substitute ni mo na value sa equation 1 here. Okay, so you can solve for TBA. Okay, so in analyzing equilibrium problems, just make sure na ma-resolve mo all forces into horizontal and vertical components. Kana lang. And once ma-resolve na nimo, apply the conditions and then solve for the unknowns. Mga sa ang kumbaga steps ba may follow ni or next problem, determine the tension in cables EB, BC, and CD necessary to support the 10 kilogram and 15 kilogram traffic lights at B and C respectively. Also find the angle theta. Now, sa problem, pag na ganun respectively, dili pwede swap, no? Interchange. So, the first to be mentioned is 10 kilograms at B, and then 15 kilograms at C. So, 10 kilograms ni 15 sa C. Again, make sure na every time you analyze a particle, make sure na there are only two unknowns. So for this one, di mo pwede kaisa ho ni mo cut like i-cut dire and then cut sa CD. Dili pwede, no? Kaya wala man nag-meet tanan forces sa common point. So therefore, you have to isolate dire B and then after that C then. So kung sa B ka, we only have three forces. Kining weight sa traffic light, tension sa AB, tension sa BC. And we have two unknowns, tension sa AB and tension sa BC. Okay. Pero sa C, dili ka pwede mag-start sa C because there are three unknowns sa C. Tension sa BC, tension sa CD, and theta. So, dili pwede, no? The only given is ang weight niya, 15 kg. So, when you analyze, you should start sa a particle with two unknown forces. So, in this case, you start with B, And then after solving for TBC, you can proceed to joint C. Okay, add joint C para ma-solve nimo ang tension sa CD and then theta. Okay. So first, you isolate joint B and then after that, joint C. So B, 10 kilograms, C, 15 kilograms. So free body diagram at B, you have 10. So we'll just use kilograms, no? And then if you want to express your answer in newtons, just multiply it by 9.81. So weight sa traffic light, 10 kilograms. Tension BC, horizontal. And then tension BA or AB, 15 degrees. Okay, since we have an inclined force, let's resolve this force into components. This one, TBA cosine 15, TBA sine 15. And since all forces are already either horizontal or vertical, then we can use the conditions. Summation of force along x equal to 0. Okay, this one, TBC minus this equation 1, no? Equation 1 lang. And then summation of force sa y equal to 0. Duwas add TBA sine 15 minus 10 equal to 0. So from here, you can solve for TBA. So transpose 10 and then divide it by sine 15. The result is this. In kilograms. In newtons, just multiply this one by 9.81. After this, you substitute this one sa equation 1, TBA, and you can solve for TBC. Kana lang. Okay. Now, sa statics of a particle or sa equilibrium in particular, there's an alternate solution to this. Okay? If if ha, if you only have three forces para sa yon. Of course, you can use this one if more than three forces, pero mas easier ang kini na style method na sa mga pag-force. We call this one the force polygon method. So, okay. Sa first polygon, i-plot nimo ang forces. And after that, na kay polygon. The result is a polygon. Pero considering na you only have three forces, ang polygon na makuha nimo is a triangle. Oh. So kung na kay 4 or 5 forces, quadrilateral or pentagon, lisod siya i-analyze. Yeah. So mas easier pag ingananin na. But for three forces, mas dali ang force polygon. So this is basically tip to tail method or tip to tail ba na sumpay-sumpay. First force, connect the second force. But considering na equilibrium ni, the resultant is zero, the tip of the last force will coincide sa tail sa first force. O sa resultant, naman to gap. If this is the first force, first force, tail nila, upward, and then this one, and then this one. So, nakay gap, i-connect na nimo, that will be your resultant. Diba? Pero sa equilibrium, wala. If this is the tail of the first force, the tip of the last force will coincide with the tail of the first force. So, walay gap ang tail sa first force and the tip of the last force. Walay gap, no? Kaya mo balik. That is equilibrium, okay? So, to illustrate, okay, we have three forces, 10, TBC, and then TBA. You can start with any of the three forces. Pero usual na procedure is you start with vertical or horizontal. Okay, let's start with the vertical force. 10. And then i-connect mo, no particular sequence. Pero for this one, TBC ta. TBC, horizontal. And then, TBA. Na, 90 degrees na kay vertical and horizontal man, so 90 degrees. The angle that TBA makes with the horizontal is 15, so not like 15. Okay, from the triangle shown, you can use trigonometry. Given ang angle, opposite side given, you solve for the adjacent side and the hypotenuse. Okay. So TBA from triangle, it's opposite over sine of angle, hypotenuse na. And it's equal to 38.637. And TBC, tangent, no? Tangent sa angle, opposite over adjacent. So it's just trigonometry, plain trigonometry. So I know kabalong basic. And as you can see, same lang result. No? That's the good part sa force polygon. If you only have three forces, kay triangle man na makuha. Not necessarily right triangle. Pwede ra oblique for as long as triangle ang makuha, and then you can use, pag oblique, you can use sine law or cosine law. And if right triangle, you can use trigonometric functions para ma-solve ang So, now, the tension BC, pwede na ito magamit. 37.32 in analyzing joints. So, sa CA, money atong forces. 15, and then TBC, 37.52. And then TCD and theta. So, ang na to is TCD and then theta. Now, resolve the force into components kay maura man yung inclined. T cosine and then T sine theta, and then use the conditions of equilibrium. This one, so two unknown, there are two unknowns, TCD and theta. Equation 1, and then summation of force of y, two unknowns Japan, equation 2. So how do we solve for the unknowns? Okay. One technique is, one solution is, you divide equation 2 by equation 1. So, this is what happened. 2 TCD sin theta divided by TCD cosine theta. I-transpose ang 15 sa right side. I-transpose ang 37 point sa right side. So, TCD sin, di ba? TCD sin theta equals 15. Di ba? And then, transpose ni TCD cosine theta equals 37.32. And then after this, cancel TCD, and you have tangent theta. 50 divided by 37.32 is 0.402. And arctangent of 0.402 then 21.897. And from 1 or 2, depende sa imo, from 1 or 2, you substitute theta, and you can solve for TCD. Same result, 1 or 2, same result. Okay. Alternate solution again, you see force polygon. We have three forces as one. Get rid of the yellow color. So 15, this one, 37, 32, TCD. So you have 15, 37.32 TCD, and the angle that TCD makes with the horizontal is theta. Okay. So use trigonometry again. Given on two sides, unknown hypotenuse, the solution is Pythagorean theorem. And the value is 40.22. Same here. And then for theta, given ang opposite side and adjacent side, then use tangent. So arctan, as you can see, same lang. Oh. Theta is 21.897. Okay. So again, in analyzing equilibrium of a particle, just make sure na all forces are identified. Identified nimo tanan forces. Wala kay ma-miss, wala kay ma-omit na force, wala sad ka nag-add og imaginary force. And then once you have the free body diagram, resolve all inclined forces into horizontal and vertical components. And then after that, once horizontal na and vertical, tanan forces, use the conditions of equilibrium. Sum up kag force sa x equal to 0. Sum up ka og force sa y equal to 0 sad. And then, if it happens na, it will result to two equations with two unknowns. Gamiton tayo nimo ang what you have learned sa algebra. Either you use method of elimination, method of substitution, or any other method para ma-solve ang unknown forces. Or the other one is you can use force polygon. Oh, but it is suggested only na it's suggested to use force polygon if three forces lang para ang makuha mo na polygon is a triangle. So if more than three forces, quadrilateral, sometimes difficult siya gamiton over kaning one. Maximum tag force sa x and y. So, regardless sa problem na ma-solve nimo, focus lang ato. Identification sa tanan forces nga nag-act, and then resolve sa components, and then apply conditions. Kana lang. And I think you can solve any problem about equilibrium sa particle. Thank you for watching. I hope that you have learned something from this video. God bless.